Oh, why, hello there, young viewer. Would you care to join me for a tale about a knight and his mathematical tribulations? Here, I'm sure you'll be interested.
Another great day here in the kingdom. I must make my way to the king. He must have an important quest for me.
And so our knight leaves his home and proceeds on his way to the king.
Halt! I forbid you to pass. To cross this wooden bridge, you must answer this question that I have been pondering since the start of time.
What is the question?
I have these pair of wings and these two rockets. One of these rockets propels you much further than the other, and I want you to find the angle between the two different flight paths that these rockets propel you to. If you do not answer my question correctly, you will not be able to cross the bridge. In fact, I will ask this witch to curse you and your entire bloodline.
Troll drops the knight, a pair of elytra, and a couple of fireworks.
Well, how am I supposed to do this?
The knight, unsure of how to tackle such a problem, walks around and finds a piece of paper.
Oh, I know now.
The knight proceeds to build a giant structure, which he uses to record the flight paths of the fireworks. He also records their coordinates.
Oh, the answer.
And how exactly did you find the answer?
I used the dot product to find the angle between my flight paths. Do you want me to explain?
Go right ahead.
I did it using the dot product. The two flight paths can be viewed as two different vectors, meaning the dot product is perfect for this. The first way you can find the dot product is by multiplying the x components of each vector and the y components of each vector and adding them together. As you can see, I placed a block to mark the point where each rocket took me. The dot product can also be found by multiplying the magnitudes of each vector by each other and multiplying it by the cosine of the angle between the two. Here we can find the magnitudes by squaring the x and y components and adding them together. Then we take the square root of it, where we finally get the magnitude.
Okay, and how did you find the angle?
Well, I simply set these two equations together and substituted values. For the first part of the equation, the x components of each vector was 39 and 33, while the y components were 21 and 37, respectively. While multiplying the x components together and the y components together and adding them, I got 2064. For the other side of the equation, I took the magnitudes of each vector. So I got the square root of 39 squared plus 21 squared and multiply it by the square root of the sum of 33 squared and 37 squared, giving us the square root of 2,458 times the square root of 1,962. We need to find the angle between the two vectors, so I divided 2,064 by the square root of 2,458 times the square root of 1,962, which got us about 0.94. This means that the cosine of the angle between the two vectors is equal to that value. Finally, we can find the angle by taking the inverse cosine of 0.94, which gets us to our answer. The angle between the two flight paths is about 19.97 degrees.
Amazing. Except, you realize that after I gave you those wings, you could have just, flown over the bridge?
Really? So I did all that work for nothing?
Maybe you should have put all that thinking somewhere else.
That's it, I'm flying away.
And so our knight makes his leave on his way to the king. Little does he know, however, that this was only the first of many trials and tribulations that he must face on this journey. But those are tales for another day.